Hey guys and gals, how is everyone doing today? Me too. I am a little bummed, I have to be honest with you. It's my first time in Wisconsin, first time at Madison Ruby. I love what Jim is doing with Madison Ruby. This is a pretty awesome regional conference so far. Looking forward to today and tomorrow. But on the drive up here, so as Jim mentioned, I'm from Alabama. It took me 13 hours to drive up here yesterday, and that's only because I use Apple Maps instead of Google. It was only supposed to be a 10-hour drive. But I'm bummed because on the way up here, the only thing I could think about Wisconsin was cheese, because I'm not super familiar with the state. And as I was approaching the I guess, Illinois and Wisconsin border coming up 94, I think, if I remember where I was yesterday, there was this booth stretched out across the road, and I got excited. I was thinking, yes, they're going to hand me some cheese as I go across the border. So I pull up, and I roll down my window, and I smile, and I say, cheese, and she says, toll? So, anyway. I still haven't had my cheese. We're not here today to talk about cheese. We're talking about the view. So I've been building software mostly for the web for a long time, about 12 years now. And the last, 6 or so of those years, I've spent a lot of time thinking about how we build these web applications. The tools, the techniques, the practices. Where I've kind of centered the last 2 or 3 years is how we architect these applications. And specifically, how we architect the view in our web applications. So this is what I want to talk about today. I want to share some of my thoughts and hopefully start a conversation with you all, get your thoughts as well. I think it's important, though, to start first with some context so that we know exactly what it is we're rethinking together. So let's start here. This will probably be a bit elementary to most of you, and that's good. So this is a View ERB template. Yeah. Woohoo! He's also smart, in addition to a gnome. So yeah, this is a ERB template. If you work in Rails or Sinatra, which I'm sure most of us have, this is familiar to you. In an ERB template, we give it some data. Here we give it an array of a single hash. And this template is compiled into what is ultimately sent back down to the client and rendered in the browser. So this is static. There's state mixed in, but it is represented as a static page. So this is kind of a compiled template here. And this is kind of a mainstay both in our community and other communities. All of the template languages in Tilt, for example, are compiled in a similar way. When I did PHP, if I can say that here, it was 12 years ago, okay? The approach that we took to views was very similar to this. So a lot has changed in 12 years, fortunately. 12 years ago, Ajax was kind of just becoming a thing. We would, at one point, list got a little long. At one point, we would have a hidden iframe and load pages through that and have a callback and refresh our content pre-Ajax. So we have Ajax support in all of the browsers, and we're even moving beyond that. We're moving to real-time apps. We're moving to apps with live updating views that update instantaneously or near instantaneously as the state in our backend application changes. And there's been a lot of work in this space. The 20 or however many front-end JavaScript frameworks that exist today. Knockback is my favorite in the list. As these have been introduced, we're kind of breaking away from the traditional roles of client and server. So pre the move to the client was really concerned about the UI, the user interface, how we interacted with the application. And our state was really wrapped up in the back end of our application. And that's changing. We've seen state trickling down ever so slowly to the front end. So this is fine, I think. It has its place. It's an extra layer, and sometimes few extra layers in our application. I think it brings some complexities, like the first request problem. If you're not rendering the view on the back end and returning it in the response, how do you do it in a way that's not intrusive to the user? A way to solve that problem is to return an empty template, make another request for the data, render the view, and present it to the user and the client. So there are solutions for these issues. I think, though, that this is really the crux of complexity, what I say, in our modern web applications. It's where client and server kind of come together. And I think they come together in the view. Now, this word crux is not a word that I used prior to like a year ago when I started kind of dabbling in rock climbing. And I've come to really like the word and like its application here. So what it is, when you're climbing a route, the crux is like the hardest part in the route. It's the thing that all of your movements have been leading up to, and you've conserved your energy, you've gotten your balance just right, and you've got to power through this last difficult move, and the rest of the route is relatively easy afterwards, as long as you get through the crux the right way. And I think that applies here. So we've had all of this work the last decade and a half, 2 decades, leading up to this point. We have browsers being built with RTC support, WebSocket support. It's becoming universal. And that's opening a lot of doors. And things are really changing. And I think this is the moment where if we get this right, it's going to make building applications in the future much easier. So to this point, we've been talking about unlocking advanced behavior like real-time views in applications with some of the application logic moved to the client. I think it's also possible to unlock this behavior in an application staying within the traditional client and server roles, so without moving state to the client. So let's talk through this. So I think of a view as a structure for presenting data. This is a view. It's the same thing we saw before. It's the result of compiling our ERB template. And so this is structure for data. Now, what is our data? So if I put this in context and say, this is a view for a blog, say we're building a blog, then we can start to kind of pick out what the data is represented here. So we can say, for instance, that this bit of structure, this div, represents the post in our application. We can say that this h1 tag represents the title in our application. We can say this paragraph represents the body. This becomes really obvious when we switch back to the ERB template. Now, our ERB template is kind of saying 2 things, right? It's talking about our structure. It's defining our structure, which are the HTML tags. And it's also describing our logic. So how do we transform this view in order to present the state from our application? And I think it's a valid question, is this bad? I don't think it is. We've built applications in this way for a long time. But like I said, things are changing. And I think that this approach puts us at a bit of a disadvantage trying to solve these other problems. What I mean is, when we compile an ERB template, it's a destructive action. The result of compiling this template is just static content. We lose all concept of state. We lose all concept of how we got to this point. The instructions that we used to build this view are gone. They're lost. We don't know how this view came to existence. We don't know where the data is. We could make an assumption, say that everything in this view is the data, the state in our application. But even if we made that assumption, we don't know, we can't put it in context. We can't put it back in context of our application. So I think we have to have a way around this. So a workaround could be to force the separation between the structure and logic. So our views, in effect, become logicless, and they are acted on externally by our view logic. Instead of transforming itself, it's acted on externally. For this to work, we have to first build in knowledge about what this view will ultimately be presenting. We do this by identifying significant nodes. A significant node is a node in our view that represents some data in our application. And as we described earlier, it's these three. It's the div, the header, and the paragraph. And then we label these. So we can say that this div is a post, and this h1 tag is a title, and this paragraph tag is a body. And we use the terms scope and prop to define these things. So a scope is, you can think of that as a type of data. Think of a prop as an attribute of that type. So transformations become relatively easy to transform this view based on how we want to present, what data we want to present. In fact, our logic that we write to transform this view doesn't treat it as a view any longer, but it treats it as data itself. So let's walk through an example of that. So here on the left, we have some data, which is a hash, and on the right, we have our view. Same view as before. It's labeled with our scopes and props. I think it's important to point out you don't usually have hashes laying around your application. This data would most likely be pulled from active record or something like that. Any object will work. And now it comes to the point where we can apply this data to the view. So we do this in a few steps, the first of which we address the view, and then we reduce our scope. So we say this is what we're representing. We're representing a scope called post. And now we apply our data to that view. So here you see that the data is just mapped in. So our title prop maps to the title prop in the view. Our body prop maps to the body prop in the view. And the content that was there in place in the view is replaced with this data. Here's the full result. Okay, so let me put this in context of a request response cycle. This is on the back end. So request comes in, it goes through router, it gets routed to an action. The action is handed this view to work with. It has the option of changing the view if it sees fit, and fetches the data and applies it to the view. And that view with the data is returned along in the response, and then rendered on the client. So this approach would also work with collections of data. So here on the left we have a collection, and on the right we have the same view as before. So what would the logic look like? Well, first we address our view, same as before. We reduce our scope. We apply our data. Now this is a little different than before. Apply, in this case, takes 2 steps, because our view represented one piece of data, but now we have 2 pieces of data that we're working with. And so the 2 steps are, one, it matches. So it matches the view structure to the data being applied. So we have 2 pieces of data, 2 posts, and our view now reflects 2 posts. Once they match, we can easily map that data into the view. Same as before. We match our first piece of data to the first post view, map its props, same thing with the second. And we're left with a view with its data in place that can be returned in the response to the client. Now, if you notice, the logic required to render this view is the same logic that we saw before with a single piece of data. That really points to the imperative nature of this view logic that we're writing. We're not saying exactly how this data should be applied. We're saying it should be applied to this view, this representation of the data, and the application process is driven itself by the data. So we don't have to say anything more. The data determines the result. Let's look at one more example. So here we have a little bit more complex data. Our view's changed. The post is the same, but we've added a nested scope underneath for comment, and it has a single prop body. Our data's changed a bit too. There's a comments key. Its value is an array with a single comment represented as a hash. So how would we apply this? Well, address the view the same as before, reduce our scope, apply our data. Now that gets us halfway there. We have our post data in place. What do we do now? Well, we open a block, and we have the option of doing more with this view. So to this block is yielded the view for the post and its matching piece of data, so the post. So in this block, we can do more. So we can address the view, which is our post view. We reduce our scope to comment, and we apply our comments. And there's the result. What I find interesting about this is that our computation, our logic, actually matches the structure that we're applying to, which matches the structure of our data, the structure of the state, how we're representing our state in our application. I find that interesting. So a bit of a recap, I want to walk through those steps again. We force the separation between structure and logic. We've built in knowledge about what the view presents. And then we've let the logic act externally on the view to transform it. So I think it's important to ask, what do we gain? It's an interesting approach, but does it really get us anywhere? So I think it does. The first thing that it brings to our applications is simplicity. It brings us simplicity in how we understand our applications. So we're dealing with data all the way down. We're building our views in terms of data, the same data that our backend application logic is dealing in terms of. Brings us simplicity in development. It's all about the hats. So what I mean by that is when we're developing a web application, there's a lot of hats that you have to wear, right? There's the front end development, there's the back end development. If you work in a small team, you're likely doing a lot of both. And with this approach, because the two are completely separated, you can work in the view space, or you can work in the back-end space, and you can think about one thing at a time, but also put it in context of the data that you're working with. I'd say it brings simplicity in the maintenance of our applications as well. So what's interesting is this opens the door to independently refactor the front end and back ends of our application. So let's say, for instance, that we no longer want to, our view no longer shows a list of all of the posts, and instead we want to show a list of all of the posts and the author of those posts. We can do that. We can completely change the view. We can say, don't show the body, show the author instead. Our backend logic doesn't have to be changed, doesn't have to do anything. Same thing if we wanted to restructure our backend logic. Because both front end and back end are described in terms of this common data model, the only time that you have to change both is when the data model changes. And I think that's a bit more than just a refactor. But perhaps the most interesting problem that this solves is it gives us a way to do live updating views. Not only live updating views, but live updating views in a traditional web application. So with the client being only concerned with UI and the back end concerned with application logic and state. And we can do this without writing any JavaScript. So this is all driven by our back end applications. So I want to show you an example. Let's see. What's the shortcut to mirror? Command. Nope. Mirror displays. Okay. So here I have an application. We have in our Vim window here, we have the same view that we were walking through before. Okay, we have a view that represents a post. We're presenting a title and a body. We have our routes. We have a route that the get route for our post, so it's the RESTful index action for our post resource. Here we're grabbing our data from our database, and then here's the application to the view. So same logic as we saw before, with the one exception, this call to subscribe. Now what this is saying is not only render this data in this view, but subscribe it to future updates. So when I say this data has changed, reflect those changes in the front end. We start the server up. So we can see that here. So we view source. Here we have our post scope. Their props and data representing the body, or with the data. Back to our code, we can look at our create action for our post. Here we're inserting a post into our database, and then we're refetching those posts and then applying them to the post scope. Now, it's a little different, right? Instead of saying view, we're saying UI. So this is saying send the data back down to any subscribed client. Any client that wants to receive these updates, push it down. So let's see this in action. So here we have our post list. I'm going to open up HTTP client, going to send a post to this route. Let's just say this. And we send it, and we see it. It's rendered on the client in real time, as soon as that application state changed. If we refresh this, it's still there. It's returned in the first request. So let's add an action here so that we can really see what's going on. Let's add one for delete. Don't make fun of my Vim foo. All right, so I think I did that right. Now you'll notice there's a bit of duplication here. We're saying this a lot. We're fetching our data and saying apply it to the post scope. I think that's a secondary problem to solve here. That is relatively easy. So let's see if this works. So let's delete the one we just created first. So there it is, it's gone. If we refresh, we see that it was in fact removed from the back end. Oops. We can create more. And we can delete at will. All right, so it seems to be working. We switch back away from mirror. Somebody needs to invent a good way of doing this. So let's dive into exactly what's happening here. This is interesting. So the way we do this is that these view transformations, our view logic, when we say view.scope, whatever, .apply our data, we can represent that as data itself. So here we see our logic, and underneath we see what our data is. We can do this even with more complex logic, because all of our logic is evaluated on the server. Nothing is evaluated on the client. We can set up something like this, where we apply it in the block. We make a decision to add a class to that view or not, based on if the data is important. And this can be represented the same. We can represent this as data itself. Now, once our view logic is turned into data, we can push that down to the subscribed clients. Our subscribed client receives these instructions and can apply to the view that was already rendered on the client, just as on the back end, those instructions are applied to the view rendering the first time. It doesn't matter where the view is. It doesn't matter where the renderer is, the thing that can interpret these instructions and apply them. It just works. So let's look at a flow to try to nail this down a little bit more. So here we have our application on the back-end server, and we have our client. So a client makes a request to our app. Our app routes it to a list function, which builds a list of posts and pushes it back down through the application in the response to the client. Now the client has a view. Now the view subscribes itself to a socket on the backend server so that it can be aware of updates to come in the future. So we have a second function, update, and update is called. It updates our state in the database. It issues a rebuild for our view, calls list, in other words. And those transformation instructions are pushed down through the socket to our subscribed views. Now there's a middleman here, a JavaScript library. I lied a little bit in the beginning. You don't have to write JavaScript, but there, of course, is JavaScript. The renderer here is written in JavaScript, UI.js. It receives these instructions and applies them to the view where we see the update. There's no transcompilation of logic from Ruby to JavaScript. There's nothing like that going on. It's just representing instructions as data and applying them somewhere else. So this is some of what myself and a few others are working on these days. We've put these concepts to work in a web framework called Pacquiao. We pushed that out a couple years ago. We've been making some steady progress since. Really exploring these concepts. So how do we simplify the development, understanding of our applications, but then how do we, through that, can we solve these tougher problems that right now are leading to more complexity in our applications? How can we make that simpler? So we have another version coming out, 0.8, in a matter of days, weeks. Includes the things that you've seen here, except for the live updating of views. Live views are prototyped. The demo that you just saw is using this prototype. We hope to push that out at the end of the year. We're really excited about it. We think it brings another option to the table for building in some of these more advanced behaviors into our applications. And 1.0 is planned. We don't have a date on it, but we really we're interested in bringing these concepts to the Rails world and to the Sinatra world. When we started building this 3 years ago, we kind of sandboxed ourselves and said, let's build a full stack framework so that we don't have any constraints, so that we can really get to the heart of this problem and try to solve it. So we're finally now through that and see a way in which we can apply these concepts in other frameworks and other stacks. And we've been, in an effort to be as inclusive as possible, we really want to bring this to the stack that you're familiar with. I hope this has been interesting. I hope maybe you've learned something. I hope that this starts a conversation. I find these concepts interesting. I would love to talk. I'd love your feedback. Like I said, I'd love to chat. I'll be here today, tomorrow. You can find me on Twitter. I sometimes blog at notmagic.org. I appreciate the time and enjoy the rest of the conference.